All right, students, this is Mr. Goods here. We're going to be showing you some how to solve some of the problems in 7.1, the systems of equations. All right, so the homework in class, we sort of went through a couple examples, and what I want to choose today, right now, is sort of clarify a couple other things that sort of come up and are a little bit more challenging. So specifically, let's take a look at number 15, because what happens is you have an x cubed, a negative 2. So this equation right here is x cubed. You see the graph, it's got a curve to it. The other equation is linear. So what's happening is the line's crossing at 3 different locations. Okay. So let's assume we didn't have the graphing calculator, and even with it, it's kind of hard to tell exactly where is the actual point. Okay, we know this goes up to 12, but it's really hard to see where the actual points are. All right, so here's our method. Our equations are number 15, 3x plus y equals 2, and x cubed minus 2 plus y equals 0. Okay, so we can do this by substitution or elimination. We did a lot in class with elimination. Let's just talk about substitution for a second. So substitution, let's take this first equation because it's a little easier, because there's no exponents. And we want to get the 3x on the other side. For substitution, we need the y alone. We want to know just y by itself. So you can walk the 3 over and make it negative, or really what we're doing, subtract 3x from both sides. You get y equals 2 minus 3x. Those do not cancel. That's what we got. Alrighty. Now, at this point, I'm going to switch to pen so I can see it better, maybe. Now we know what y equals. We can take this and plug it in over here for y. What I mean is we can take our equation over here now. It's x cubed minus 2 plus, and instead of y, we're going to replace y with this whole thing here. 2 minus 3x. If it helps, sometimes I put a parentheses. So you see y was replaced with this whole thing. So it's our original equation, but instead of plus y, we replaced y with this, because that's what it is. All right, now let's clean this up. X cubed minus 2 plus 2 minus 3x equals 0. All righty. Those will cancel each other out. It's looking better already. X cubed minus 3x equals 0. Okay, now, in earlier chapters when we had x cubed, we did things like synthetic division and things like that. But this one's just x cubed and an x. There's not a whole lot of other stuff in here. There's no other stuff. So if we look just at these two, we say, oh, they both have x. Let's factor out an x. If we do that, what we have here is x squared and then minus 3. Now, why in the heck would we do that? Well, what it is now we have this times this equals 0. The only way two things multiply to make 0, either x is 0, which is making the whole thing 0, or what's inside here is 0. Oops, x squared minus 3 equals 0. Well, x equals 0, that's solved. X squared minus 3 equals 0, well, if we add 3 to both sides, we get x squared equals 3. If we square root both sides, we'll get a plus or minus square root of 3, or just x equals plus minus square root of 3, and we'll leave it like that. So those are our two answers, but they're not exact answers, because let's go back to what we're really solving here. We're solving a question of where does these graphs cross? Where do these graphs cross? Well, we know the x locations where they cross, but that's not a complete point. We need the rest of the point. Okay, so we're going to have to take these and go plug them in. So over here, you can take either equation. Our original equations were 3x plus y equals 2. Or if you want to take the one with exponents and more values and a negative, you could do that. Personally, I think the top one's a little easier. So we'll redo it. We're going to say find the y values. Okay. So we're going to use our equation. We're going to let x equals 0, and we're going to plug it into 3x plus y equals 2. We also have to evaluate these two ones also. So we have to evaluate x equals radical 3 and also x equals negative radical 3. And we're plugging all those into this equation, 3x plus y equals 2. Yes, what it is all of these are values of x. We need to find the y values. So if we plug 0 in here, we get 3 times 0 plus y equals 2. That's just 0, so you just end up with y equals 2. So x was 0, y was 2. That's one of your points. For this point, you plug in the square root of 3. You're going to have 3 times the square root of 3 plus y equals 2. You cannot multiply these. You can't do any more simplifying. So move it to the other side, subtract it from both sides. Get 2 minus 3 rad 3. So our point there was rad 3 and 2 minus 3 rad 3. That looks kind of messy, but that's a 2 minus, and I should have written better, but my apologies. So t times negative rad 3 plus y equals 2. So for this one, you get negative 3 rad 3 plus y equals 2. Add this to both sides, you get y equals 2 plus 3 rad 3. So our values there are negative rad 3 and 2 plus 3 rad 3. Okay, let's see if these make any sense. Okay, we can do this. You can check it here. Like I said, one's on the positive side, one's on the negative side, and one is at 0, and it does look like it's 0, 2. That's what we found, 0, 2. One has a positive x, one has a negative x. This value here, we could estimate with the calculator and see if it matches up. But really what it is, now you see the value of the graph. The graph's good, but it's not going to get you exact numbers like rad 3. That you'd have to use the algebra for. Okay. One final